Welcome to All About Homes, filmed right here in Myrtle Beach. You'll get to meet professional builders and businesses as they showcase their work on how you can make your home the best it can be. No project is too big or too small, and these companies guarantee that the job will be done right. We're going to get dirty, but we're also going to have a lot of fun. This is All About Homes. Today on All About Homes, we head to Carolina Forest to meet Tom Baker with Buildgreen Industries as they showcase their latest energy-efficient home. Then we'll head over to Horry County Solid Waste Authority to talk about how recycling can spruce up your home. Plus, we'll get some great listing tips from Plantation Realty Group. It's time to get dirty, or in this case, green. Welcome to another exciting edition of All About Homes, a very informative edition of All About Homes. In fact, go ahead and grab your pen, your paper. You're going to be taking lots of notes today because we're talking about building green with Buildgreen Industries today here in Waterbridge. Beautiful community, beautiful home behind me, and a very energy efficient home. I know you've had questions before. You've probably heard terms like ICF before. We're going to explain those and dig real deep into all of it and how it all works. So come on inside and let's see what it's all about. All right, we're talking about energy efficiency today. I know you've heard that term, seen the term on your appliances at home. It's certainly becoming a more popular thing, which is certainly a good thing as well, but it's not all about appliances. We're actually talking about whole homes being energy efficient, and we've got the man who does that right here, Mr. Tom.
Nice to see you, Rob.
Buildgreen Industries, right?
Yes, sir.
All right, well, we're talking about an energy efficient home, which you're building right behind us here, and we're gonna go through the whole thing, but just tell us a little bit about how energy efficient this home is gonna be in the end.
Well, how this house is more efficient than other houses is that the normal rating for a house for houses built to 2012 energy codes is a HERS rating of 100.
Okay.
An Energy Star house that what people are familiar with as far as the terminology would have a HERS rating of around 80. This house is expected to have around a HERS rating of 40.
Wow.
Which means that it uses 60% less energy than a house built to 2012 energy codes.
Wow. How does that start? Like what's the shell?
Okay, the important things about an energy efficient structure is that you build an envelope that doesn't take much energy.
Right.
And so in our climate in South Carolina, what we determined would be the best, because we have two benefits from it, is that we build it out of ICF.
Okay, ICF, what is that?
ICF means insulated concrete forms.
Okay.
So what we do is that our exterior walls are all 2 inches of styrofoam, 6 inches of concrete, 2 inches of styrofoam. And what that allows for is that I encapsulate concrete with a insulation on both sides, so I don't get any energy transfer from the outside and I don't get any energy transfer from the inside.
Gotcha.
So I have insulation on both sides of the form.
So we've got a closed system here.
That's correct.
Gotcha.
And that's the basis for which we would start with a house, and that's how we get probably the most benefit in our climate. Because when you build out of concrete, not only do you take care of your energy, but you have a secondary benefit in that it'll take a much higher wind load.
There you go.
So in South Carolina, because we would have hurricane events and other events that would cause a wind load on this, is that wall will stand on its own accord as much as a 200-mile-per-hour wind without the roof diaphragm, so the wall is independent structurally.
Okay, and a third benefit actually too is the sound. It's kind of a great sound barrier too, right?
Well, it's a much more quiet house, and it doesn't let any air infiltration in either.
Right.
So you don't hear the noise from the outside. And basically it's almost bulletproof.
Okay, well, hopefully we won't need that, but but this is just the outside. We got a lot more inside, so let's go inside and check that out.
Okay.
It's time to head inside and see these ICF walls in place, and trust me, they are solid. All right, so we saw what the ICF looked like on the outside, but this is what it looks like on the inside here. Tell us about what we're seeing here.
Okay, basically what you saw on the outside was the concrete forms. So we have an 11-inch wall assembly here that has 6 inches of reinforced concrete. We have 2 inches of styrofoam on the inside. We have 2 inches of styrofoam on the outside. It totals up to be 11 inches. And then we basically put rebar in both directions. So what we end up with as a finished product is a reinforced concrete wall that's 6 inches thick, that's solid and isolated from the outside environment.
Solid, yeah. Listen to this. That's pretty solid.
Yes, sir, it is very solid.
Now, part of the system also is the floor itself, and we actually have a crawl space, right?
Right, well, basically what you have as a crawl space on this assembly is that we did a raised concrete floor, and we have a concrete pan in here, so we have a 40-inch crawl space underneath there, but there is absolutely no wood assembly or anything, insulation or anything else, because we isolate the exterior walls downstairs, and so this acts part of our thermal envelope. And so if this stays stable as a temperature, then the house does, but basically it's 6 inches thick here, and from a cost effectiveness is that the raised concrete floor is not any more expensive than filling this up with dirt and then pouring concrete on top of it anyways.
And it gives you access in case you need to do anything under the house as far as adding anything to the floor.
Well, what's very nice about this thing, if you had a plumbing leak, or let's say you want to change your bathroom, I can go underneath the floor, change the plumbing without having to dig the floor on top that you would do typically. And let's say in the living room, if you wanted to put an outlet in the floor someplace, you can just drill a hole, bring power there, because you have access underneath the whole house.
Gotcha. All right, well, we're just scratching the surface here, so let's go check out what else is going on in
Okay,
this thing.
we can do that.
Coming up on All About Homes, we're back with Buildgreen Industries as we see more of this amazing home. Stick around.
This energy saving tip is brought to you by the Horry County Solid Waste Authority. Use Energy Star appliances. An Energy Star washing machine can save 50% more water compared to a standard model. And cold is better. 85 to 90% of energy goes into heating water when washing clothes. Use cold water instead.
Well, we've seen the base and legwork from this ICF home, but now it's time to see what's upstairs. All right, so we were talking about the concrete floor, Tom, here on the first floor, but actually upstairs, you got more concrete, right?
Yes, sir.
So this
So
thing,
we have a concrete diaphragm on the first floor.
yeah,
And then we have a concrete bar joist system by EchoSpan, a Volcraft system, which is more typical for commercial projects, but it's applicable for residential because it's a lightweight system that's cost effective from the point of view is that it doesn't cost any more to put this bar joist system on the concrete, but it adds a lot for durability, it adds a lot of fireproofing, and then if you actually can see through here, is that I can bring wires or mechanical systems throughout the whole house in any direction without any impediments that you would get from solid beams or wood construction. Plus, the house can't burn.
okay, it's almost like a drop ceiling, right?
Yes, sir.
Okay, and then the concrete up there on the floor, that's what, 3 inches?
Yeah, this is actually considered a lightweight bar joist system in that we only need 3 inches of concrete over there. But in fact, I only have 28 pieces here and they're every 5 feet, so I don't have as many components to install, and it's far stronger than a normal wood system. And if we go upstairs, you'll see how stiff the floor is and how solid it is.
Okay.
And it also makes the house soundproof.
Awesome. Let's check it out. All right, so upstairs here, this is kind of interesting. What looks like you call this the spaceship?
This is the spaceship.
This is the
Yes, this is
spaceship.
kind of the spaceship ready for takeoff.
Now you got some kind of lining in here. What is that exactly?
Well, what we do is we put a radiant barrier in here that's perforated that allows heat, the infrared, so whatever's in stays in and whatever's out stays out.
Gotcha.
But it's perforated, so the moisture transfers across the membrane, so I get a drying effect inside the building, so I don't have any mold issues.
Gotcha,
That's why
okay.
we put it on there.
Well, now insulation. Let's look in this room over here.
Okay.
You got some interesting stuff here. What is exactly this spray? Some kind of spray foam?
Well, what we're using here, we actually use 2 different products. We use an isonine product, and there's 2 types of isonine. One is a solid base material, which is a 2-pound density, which you can feel it's hard.
Yeah, it's real hard.
Okay, and that's called closed cell.
Okay.
And then we have open cell isonine, which is soft.
Right.
And the closed cell basically glues the whole structure on. So if you wanted to get the piece of plywood off, you'd have to break the plywood. And so when we envelope the house, which is really as an important component as the ICF walls on the outside, is that we totally isolate the outside environment. So all my crawl space, conditioned, unconditioned space, does not have any way for air infiltration doing.
Right.
So if you
So it
look
means
back,
it's not going to get extremely hot. It's not going to get extremely cold.
that's correct. But if you look back along the sill plate here, we do no venting in the house whatsoever. So this is an unvented house, so it's considered a very tight house.
Yeah. All right, let's talk about the roof a little bit, because I mean, most people think roofs, we're just trying to keep the rain out or whatever, but there's a lot of energy efficiency in that as well. Tell us a little bit about what you did here.
Well, what we have for a roof here is that we used a metal roof because a typical asphalt shingle roof, which is more common for the area, actually is the most common roof here, absorbs all the heat. And because we have such a high temperature here, and a typical asphalt shingle roof will outgas, so after 7-10 years, it's pretty much worn down.
Right.
It loses the stone, it loses the other components. On the roof that we use here, we use a metal roof, and the cost of the metal roof allows us to be competitive with an asphalt shingle roof, but it lasts 3 times as long. In the way that we build a house, our attic space is basically the same temperature as the rest of the house.
Yeah.
But even when it's 100 degrees outside, our attic space is probably in the 80s.
Wow. So really, from top to bottom, we're covering everything to keep this thing airtight and energy efficient, right?
And basically the idea is to keep the environment outside. You wouldn't want the environment to inside, so why would you want 140 degrees inside your house?
Right.
And all the moisture associated with it, because when you put 100-degree air inside, 140-degree, it's very high humidity, so you're also bringing humidity in the house, and it's very hard to deal with it. And if you just leave it outside, you don't have to deal with it at all.
All right, so we went from top to bottom. We've closed this thing in, because we said earlier it was a closed system, right?
Yes, sir.
All right, but you talked about you got to pump in your own fresh air, so how are we going to do that?
Well, we have to go inside, and I use an energy recovery ventilator that transfers the air from outside to inside, and then I dump the air from the bathrooms, really, instead of having regular bathroom vents.
Yeah.
Is I take the air outside through a mechanical system.
Okay, let's go check it out.
Okay.
All right, Tom, I'm really excited about this because we're talking about some geothermal stuff here. People have heard of it again, they don't really know anything about it. We're gonna go outside and look at how it all works in a minute, but this is the unit actually that's gonna be heating and cooling
The whole house.
the whole house.
Right.
And so there's no exterior unit, just this.
Right, there's no fan coil unit outside. Everything that's necessary for air conditioning in this house is in this unit. So we have the compressor in here, we have the fan coil unit, and so all the air is being pulled into here, and then I bring it out through the house.
Okay.
What's interesting about the house, because we envelope the house, we only need one system. So I can heat and cool this house, 3,500 square foot, with a single system in
I was
here.
going to say, now wait a minute, 3,500 heated square feet, people are using at least 2 units typically.
Absolutely.
And this one unit is going to do the whole thing.
This one unit, I'll guarantee it does a whole unit.
Wow.
And in fact, the way that we envelope the house, this house would typically have 7 tons or 4 tons, and 4 tons downstairs, 2 tons upstairs of air conditioning unit.
Yeah.
I use a 4-ton unit, but because of the way we envelope the house, I only need 2 tons. This particular unit, because it's well made, has a 2-speed compressor, so I'm only using 2 tons.
Now, what's the SEER rating? I heard SEER rating, basically, the higher the better, right?
Right.
And we just moved up to stuff that's like 13 to 15.
Well, code requirements, you got to have a minimal of 14 SEER.
okay.
It used to be 10 SEER, and
Right.
that just tells you how efficient it is for every unit of electricity, how much heating and cooling you get.
Yeah.
So on a 10 SEER, which is a very inefficient, you get 1 unit of cooling per 1 unit of electricity. It's a little bit varied on that. Well, what happens is that the very best air conditioning you can use right now that's air to air, which is when you have the fan coil unit outside,
Right.
is 18 SEER.
Uh-huh.
This unit right here is 30 SEER. So I'm twice as efficient
That
as
doesn't
a
even sound
unit.
fair. All right, well, before we get outside, I want to talk real fast about, because we're going to have our hot water heater up here too. Now, the hot water heater itself, it will be hooked up to electricity like normal hot water heaters, but it's not really using that electricity. We're using the hot water they're using in the house and stuff.
Right. What geothermal technology is that you're transferring the energy in water. As soon as you put the energy in water, I can move it.
Yeah.
So what this unit has is I have a thing called a separator, and so I take the heat that we'd want to dissipate from the house, and if I put the hot water heaters over there, is I take the heat from the house and I put it in the hot water heaters. That allows me to consume the heat that we normally would take out of the house, and I'm not using other fossil fuels to heat the hot water redundantly.
Right.
So considering a house this size, I'm going to be dissipating quite a bit of heat. You live here, you take a shower, you cook. So instead of taking the heat outside, I capture that energy that I've already paid for, and I put it in my hot water heater. And so when I take a hot water shower using that energy, I actually make my geothermal system more efficient.
So we're
more
reusing,
effective.
being efficient. I like it.
That's correct.
All right, well, let's go outside and check out those geothermal tubes. I'm excited to see that stuff.
Let's go.
Coming up next, we're heading out to the Solid Waste Authority, where they're going to show us how some recycled material can help spruce up your home.
Hi, my name is Jennifer Yotis with Plantation Realty Group here in Myrtle Beach. Are you considering selling? We get questions a lot as realtors on how to sell your home quickly. Here's a few quick tips. If you don't need it, pack it up. Potential buyers want to feel how spacious your home can be. So start packing up the non-essentials, get them boxed up and ready for the movers. Take down those family photos. Buyers want to envision themselves in your home, and having a bunch of personal photos out makes that a bit more challenging. Get rid of those items you don't need. Selling your home can be a great time to empty out those closets and get rid of those old clothes you never wear. Any old gadgets and appliances you don't use can clutter your space, so get rid of those. For even more tips, call your Myrtle Beach real estate experts at Plantation Realty Group at 843-796-2111.
For all your real estate needs, make sure you call the experts at Plantation Realty Group at 843-796-2111. Coming up, we finish the day with Buildgreen Industries as we're shown the geothermal system that will cool and heat this home.
This energy saving tip is brought to you by the Horry County Solid Waste Authority. Bamboo is better. Bamboo is the fastest growing plant on earth. This quick, ready replenishment means it's more environmentally friendly than timber trees to use as hardwood flooring.
All right, Tom, so we were upstairs looking at the unit that's going to actually heat and cool this place, but the energy itself is coming from right beneath us, right?
That's correct.
Geothermal.
Ground source heat pump, or geothermal, that everyone's used to, but in South Carolina we have a perfect climate because we have 67-degree ground temperature for 500 feet. So how I handle this problem is that I use the surrounding ground, so we have so much dirt here, so there's lots of capacity for exchanging energy because we have a lot more dirt than we have house.
Right.
One thing that's really nice about South Carolina, Myrtle Beach, is that our ground temperature is almost our comfort level temperature. So we're going to be using the stored energy of the ground to heat and cool our house because it's already here, and it has always been here.
It's free.
It's free.
Who doesn't like free?
Right, exactly.
Well, let's go to the side of the house and see some of these pipes, and you can kind of maybe explain a little bit more for us, okay?
Okay, let's go over there.
All right, so here we're on the side of the house. Our pipe's actually going up into the house. We were upstairs earlier where that was coming at. So tell me what's going on here.
Okay, what we had inside the house, because we built a very energy efficient house, is that we need makeup air to bring in fresh air.
Right.
So in the house that I think is correct for South Carolina is that we bring fresh makeup air in, but I bring it in through a pipe. And so this is for the geothermal heat pump technology. And then what this pipe is and basically I would call it geopiping, and it gets a little confusing, but in basic,
this has water in it, this has air.
Right, and basically what I'm doing underground, so when we come out of the house, I'm actually bringing the air into the house through this pipe.
Right.
But if we want to, we can follow this around, but I basically use a pipe that I can exchange in, so I bring air through this pipe from over there, and so I have about 200 linear feet of this piping that terminates over here. So I pull the air in, you'll see the inlets over there, but when I put it in the dirt, I'm actually dehumidifying the air. When it's 70 degrees outside, I can just bring in outside air.
Right.
But when it's 100 degrees outside, when I bring it into the ground, I'm tempering the air with the free temperature change that's in the dirt.
Right,
the capacity of the dirt.
Basically, the air that goes into the tube is actually becoming 67 degrees.
That's
which
correct.
is what the ground is. So by the time it gets into the house, it's coming through at 67 degrees.
Right. So if I bring in air at 100 degrees, it should be coming to the house at 80, as if it's 80 outside, which is a lot of energy to dissipate.
Right.
What's even better, if it's 28 degrees outside, instead of bringing in 28 degrees in, I'm bringing it up to 50, 55 degrees.
Gotcha.
So I almost have a 20-degree temperature drop, and the colder or hot it is, the more value I have on it.
Okay.
And so that's why it works. And the only cost of this system, really, because I'm putting the geopipes in, is the cost of the pipe. So we can do it simultaneously.
Wow, okay. Let's go check out where it actually comes in at.
We'll show you on the other side. what happens on this pipe here is that this pipe goes all the way back to the other side. I put a screen here, and these two allow the air to go in. And when I put 2 pipes in here, you'll notice it's one back over there.
Right.
There's 2 here, but the reason I put 2 here is that I get more exchange until I get up about 60 feet, and then I go back to a single pipe.
Okay.
But I get more exchange out of a pipe. The air slows down in here.
So these will join up together down the road.
Right.
Gotcha.
Right, but these are the air inlet, and so I'm 160 feet away from there, so I have 160 feet of pipe underground that allows me to exchange energy.
Gotcha. Which is what basically the heating and cooling, that's the exchange itself.
It adds capacity to the system. I'm only using a 35 watt blower, so I'm just using a blower that just pulls the air through. So when you open and close the doors, I'm not bringing dust into the house, I'm actually pushing a little bit of fresh air out, but this fresh air is free.
Right.
And I'm not taking the energy to temper it in any sense.
Until they start charging us for air, right?
Well, when they start charging us for air, they're on another matter there.
All right, excellent. Tom, thank you so much. It's been an excellent day. I've learned a whole lot. My brain's a little it's overflowing right now. But bottom line is this is about energy efficiency, right? Amongst many other things.
Right. I mean, this is the way you'd want to build a house. If you want to build an energy house in South Carolina, Myrtle Beach, you need to have certain components in there which makes everything work for you much better.
Well, you seem to know all of how that works and everything else, and you do an awesome job. We can't wait to see what the actual bills are going to be. I'm sure they'll be pretty tiny once you get it all done.
Well, we should use 60% less energy to heat and cool this house than a house built in today's energy code
That's
compliance.
amazing. All right, well, thank you for all the information. We appreciate it.
Thank you.
And with that, our day is complete with Buildgreen Industries. If you want to head the energy efficient route, make sure you give them a call or check out their website at buildgreenindustries.com. That's another episode of All About Homes. We'll see you next week.